questions because I thought like we just finished organic chemistry. At least organic chemistry we can remember a little bit, but also I know like what are the areas that you all are struggling, and then we will be taking questions from lessons like mole calculations, titrations, all these chemical calculations, and also enthalpy changes, equilibrium questions. Also, we will separately discuss. Today, we will discuss questions related to organic chemistry. From that, I have taken mainly the lessons coming under alcohols, carboxylic acid, and the polymers. Right. So, with the question, I will revise any theory knowledge that you need to do the question. Right, now we will do a question from 2018 May 21 paper. This is the question number 4 in that paper, paper 2. Right, this question is about ethanol and ethanoic acid. Now, before we go to the question, guys, so we have alcohol. When we name the alcohol, we use the suffix OL. So ethanol, because ethan is because there are 2 carbons in the carbon chain. So ethanol is also can be drawn like this. And also we can draw the displayed formula of ethanol. When we draw the displayed formula of ethanol, now displayed formula shows all the bonds and all the atoms in the molecule. Now this is not the displayed formula. So if I want to draw the displayed formula, what I do is I have to put carbon atoms. There are 2 carbons, right? So 2 carbon atoms. There can be 4 bonds, so I can put 3 hydrogen atoms to this carbon, and to the second carbon we can put 2 hydrogens, and then OH bond we have to display like this. This is ethanol. It has 2 carbon and it's an alcohol. Ethanoic acid is a carboxylic acid which has a formula like this, CH3COOH. And when we draw the displayed formula of ethanoic acid, we have 2 carbons. 1 carbon is a CH3 group. The other carbon has double bond O and OH. That also just came, there's a few you need to collect. Right, that is ethanoic acid. Now see the difference. In ethanoic acid, you have an extra oxygen, right? And in ethanol, there's only 1 oxygen. Right now, we study about ethanol and we learn how to make ethanol. Biological process is fermentation, right? Fermentation. Now, when we prepare ethanol using fermentation, right? What we do is we have a reactant. We use a sugar. We dissolve sugar in water and make an aqueous solution, right? So you take sugar and add it to water and make a solution. Then this reaction will be this reaction is carried out in the absence of oxygen, right? So what we do is we have to close the lid of the beaker or the container. Otherwise, oxygen will react with ethanol when it's produced. Also, there are other conditions we need, right? We need reactants like sugar. We need to mix it with water, right? And there are other conditions. Let's see how many remember conditions that we need. How many remember the temperature we need? It should be less than around 30 to 40, right? 30 to 40. Because if we use very high temperature, we'll come to that. If what happens when you use very high temperature. Right, so temperature is important. Other than temperature, we had another substance. What is that? We had yeast. Right? So yeast, the enzyme in yeast that is going to catalyze reaction. Right? So enzyme in yeast will catalyze the reaction. Now the thing is, this enzyme in yeast will break down, or we call it denature, at high temperature. Right? So if you use very high temperature, the enzyme will break down. Then enzyme can't catalyze the reaction, right? So enzyme in yeast will break down if you use very high temperature. Therefore, we can't use very high temperature. Optimum temperature should be used, right? So temperature around how much? 30 to 40, right? Yeast should be around sugar should be dissolved in water. Anaerobic condition means we should carry out the reaction in the absence of what? In the absence of which gas? Oxygen gas. Okay. Right. Now we'll go to the first question. It's related to ethanol. It's too loud. It's okay. Right. Part A. Right. We have ethanol and ethanoic acid. Right. Describe the manufacture of ethanol by fermentation. Right. Now let's. You can take a pencil and quickly write down the full answer. Huh? You have tried. Right. So we're going to describe manufacture of ethanol by fermentation. So first thing that we need to write, if we can write down, add sugar to water and make a solution. So that's important, right? So we need to make a solution of sugar. Right. Now then we need to add another substance. What is it? Yeast. Then add yeast. To the solution. Right. Then what we do is we have carry out this reaction at a certain temperature and in the absence of what? Oxygen. So carry out the reaction. In the absence of oxygen. In the absence of oxygen and at 30 to 40 Celsius. Add. Right now the thing is, still we won't get full marks. Surprising. Right guys, now what are we doing here? We are making ethanol using fermentation. Now when we add ethanol to yeast and then to solution of sugar when we add yeast, right, and maintain it at this amount of temperature to 40 and carry out the experiment in the absence of oxygen, right, ethanol will be formed, right? But this ethanol, we can't sell it. Anyway, we can't sell ethanol. You can't drink ethanol. But this ethanol is useless still. Why? Because it's with other impurities, right? So there's yeast, there's water, everything is there. So what's the last process that we need to do? Use fractional distillation to separate ethanol from the reaction mixture. So that is something that many students didn't write. Right? When I give this question, many students didn't write that part. When you make ethanol, the last part is important, fractional distillation part. So don't forget that. Right? Write all the reactants conditions. Also write down. Then separate ethanol. Using fractional distillation. That's really important, right? So you get full mark if you write fractional distillation at the end. Right now, there are two types of distillation we have learned. We have learned simple distillation and fractional distillation. Now, simple distillation is not suitable when we extract or when we separate ethanol from water. That's because ethanol and water have almost very close boiling point, right? So therefore, best thing is use fractional distillation. Simple distillation is used when we separate water from solution of sodium chloride. So let's say you have salt solution, sodium chloride, and if you want to separate water from salt, you can use simple distillation. But in this case, we must use fractional distillation. Right. We go to part B now. Now today's our first day. Okay. Now you will see for many questions, sometimes we can't answer many questions in the given tune. But the idea is if we do a lot of questions with time, you will understand what kind of answer you need to write down to get full marks. Right. Now let's go to part B. Ethanol can be oxidized by oxygen to form ethanoic acid. Right. Ethanol can be oxidized. Right, guys. When we say oxidation, right? Oxidation can be defined in many ways. Right. So oxidation is removal of electrons. We can write down. Oxidation. Removal of electrons. When you remove electron, we say the substance is undergoing oxidation. Sodium becomes Na plus, right? Na plus by removing one electron. Magnesium becomes Mg2 plus by removing two electrons. So oxidation is a process where we remove electrons. Always during oxidation, you see the charge increases. But sometimes we can't identify using this method directly in O levels, right? So we have another method. Adding oxygen is also oxidation. Adding oxygen. Adding oxygen to a substance is oxidation. SO2 when it becomes SO3, that's oxidation of SO2. SO2 gains another oxygen, so it becomes SO3. So that's oxidation, right? So adding oxygen. That's another way. Removal of hydrogen. So last two methods we can use in O level to identify oxidation. Adding oxygen is oxidation. Removing hydrogen is also oxidation. So reduction is the opposite of this. Right? Reduction is adding electrons. Adding electron is reduction. And removing oxygen is reduction. Right? Adding hydrogen is reduction. See, when you study oxidation and reduction, when you study about oxidation, you automatically know about reduction. It's the opposite of that. Right? So use that method. So now we have to construct the equation for this reaction. Right. Now we are oxidizing ethanol to ethanoic acid. Ethanol we're gonna oxidize to ethanoic acid. Right. So shall we try and write the reaction? So ethanol is CH3CH2OH or C2H5OH. And it reacts with oxygen. So the other reactant is oxygen. And it forms ethanoic acid. Now ethanol and ethanoic acid, they always ask in the exam. So you have to know their formula well. Right? Anyway, even if you don't know, it's given. See? So ethanoic acid is CH3COOH. So the product is, one product is ethanoic acid. Then there's a byproduct. Now guys, usually when hydrocarbons react with oxygen, remember, carbon dioxide gas is formed and another product is formed. What is that other product? Water, right? So here also, when ethanol reacts with oxygen, ethanoic acid is formed, not carbon dioxide. Because they have clearly said ethanoic acid is formed. and the other product is H2O. Now check whether the equation is balanced quickly. Check if the equation is balanced. Carbon atoms, hydrogen atoms, do they all check? Balance, right? So the reaction is balanced. This is how ethanol is oxidized by oxygen in air. But this also requires catalyst. Again, bacteria, enzymes will act as a catalyst for this reaction. Right. We go to the next part, part C. Right, sample of ethanol is heated with ethanoic acid in the presence of concentrated sulfuric acid as a catalyst. Underline that. You all need to take the tube. Right, guys. Now, alcohol and carboxylic acid, when they react, so we can write down if an alcohol reacts with carboxylic acid. Any extra note you need to quickly write down. Huh? When I write down, right? We can react alcohol with carboxylic acid and in the presence of concentrated sulfuric as a catalyst. It forms a molecule called ester. Have you heard about esters? Right? Esters, they have nice smell. Right? We use esters in perfumes. They have a nice smell. Also, esters are used as solvents. Right? So esters are very useful. So ester is one product and water is removed. This is a general reaction when alcohol reacts with carboxylic acid. Alcohol can be neutralized by carboxylic acid. Now that's the reason why when people are drunk, they are given lime juice, right? Lime juice contains carboxylic acid. So carboxylic acid and alcohol, they react with each other. So alcohol is neutralized. So alcohols always react with carboxylic acid, but there is a catalyst. Concentrated sulfuric is the catalyst for the reaction. Yeah. I'll answer that later. Right. Right. So the thing is, you don't have concentrated sulfuric acid in your body. What happens is the enzyme catalyzes the reaction inside the body. Okay. Inside the body, they form ester. Ester, yes. So it was nice inside the body. Huh? So it was nice inside the body. Should be, no? Right. Okay, guys. Now let's learn how to draw the structure of an ester of a product of this kind of reaction. Right. Now everyone should look at the board. If you know how to draw the structure, you can draw. Otherwise, please look at the board. So we're gonna write down we have to write the structure of the product of this reaction. Now when you write the structure of the product, this is the method. Everyone look at the board. Right. So we have two reactants, alcohol and carboxylic. So let's say I'm gonna draw the carboxylic acid first. Now they have asked for the displayed formula. Remember, show all the atoms and all the bonds. That means displayed formula. So we have to draw the structure of the ester in displayed formula. Right. This is the method that we must use. So, right. Now this carboxylic acid, ethanoic acid. We can draw it like this. Now, anyway, in the paper, they have given the formula of ethanoic acid. Ethanoic acid is this. Now we have to combine this with ethanol. So when we draw ethanol, there are two carbons, OH bond. Like that. Now these two will react and they form an ester. Okay. Now when we combine the carboxylic acid and alcohol, you must do like this, guys. Okay. You must remove the H from alcohol and OH from carboxylic. Now quickly draw this up to this point, right? Then I will show how to draw this product. So we have to remove the OH from carboxylic, H from the alcohol. Right? Quickly copy down that part up to this part. But this is not the final answer, okay? So remove the OH from carboxylic, H from the alcohol. Okay. Right now, when they react, now have a finished copy. Right. Now look at the board. First, I will show you what happens here. Right. So this carbon will lose the bond with oxygen in carboxylic acid. So let's quickly look at that. Right, when I remove the OH, that carbon lose that OH group from carboxylic. And this H will bind to this OH. That's how water is formed as a byproduct. Right? OH group from here binds to H, then they form water. Now the thing is, after this happens, look at this guys, don't copy. See, this carbon needs one more bond, right? Carbon is one more bond, right? Carbon has to complete 4 bonds now. So this oxygen also needs another bond. Oxygen usually complete 2 bonds. But then what happens is, this oxygen and carbon bind to each other to complete the bonds for them. So when you draw the product, so water is a byproduct. When you draw the product, do like this. First draw this part of the molecule. So in the ester, carboxylic part we can draw first. So I'm going to draw that part, okay? So nothing is changed, just CH3 group like this and C double bond O. Now look at this part is important. Everyone look at the board. So after you draw up to this point, right? Up to this part of the structure, next you have to combine oxygen to the carbon. So this oxygen we need to combine to the carbon. So when I draw, I put oxygen here now to the carbon. Then after that oxygen, what do we have? We have a CH2 group. Then after the CH2, we have a CH3 group. So after that oxygen, how many carbons are there? 2 carbons, right? So put 1 carbon, second carbon, and now fill the hydrogen. We can put 2 hydrogens here. We can put 3 hydrogens here. Then we can complete the hydrogen atoms like this. So this is the structure of the ester that we have to draw. But to complete the node, we will write the structure of the ester and also put water as the byproduct. So we are going to do another example after this. Right? This side. Okay. Okay. Did you finish? Once you can do it. So this is the final answer. Now in this question, they have asked us to draw the structure of the product ester. So that's what we need to draw, but I have given a full answer here, so we can complete the note there. Right. Now what we can do is we can do another example. Right, we can do another example, guys. So we have now I'm going to give another question for you all to do. I'm giving the structure of an alcohol and a carboxylic acid here. There's a small delay here. Right, have you finished coming? Okay. Ready to do an example, another example? These days, network is horrible, no? This dialogue is stupid, useless. Network. Huh? Sri Lanka, we are living in Sri Lanka. Right now, I'm going to give another one. Right, quickly complete this one. Right, so there's a carboxylic acid here, and there's an alcohol like this. Now these two are reacted in the presence of concentrated sulfuric acid. Water is the byproduct and ester is formed. Right, you will quickly draw the final answer for the ester. So, no, complete it in the tube. Yeah, right.
Sir, is this the homework?
That part is. Yeah, quickly do. Oh, not homework, man. Finish now.
You have to do this. You told to do this homework and come before the vacation.
In page number 3, you can do.
So you told.
Yeah. So do it in page number 3. If you don't have to, quickly take another paper and do. Yeah, go to vision camera. Okay. Really? No, page number 3. Between page number 2 and 4, what is it? Right, okay, I think it's enough time. How many of you have completed it, guys? So remove H from alcohol, OH from carbon. H from alcohol, OH from carboxyl. Carboxylic is the one that has double bond. Right, now we're going to remove the OH from carboxylic, H from the alcohol. Right, now we're going to draw the structure. Right, there are 3 carbons in the carboxylic side. So we'll start with carboxylic part. So I'm going to draw this part. Right, so the CH3, CH2, C double bond. So draw up to that. Draw up to this carbon. Now then connect this carbon to the oxygen atom. Now even though I have written I have drawn the molecule this way, now to flip the molecule when I complete the structure of the ester. So oxygen should bind to this carbon. So how many carbons are bonded to that oxygen? 3, right? So draw 3 carbon atoms. 1, 2, 3. Now each carbon atom will bind to hydrogens. So we can put 2 hydrogens to these 2. Because carbon can only have 4 bonds, remember? We can put 4 hydrogens to 3 more hydrogens to the last carbon. Like that. Right, did you all get this structure? Got it? As long as the structure is correct. You can draw the molecule in any way. Right, okay. Now we can learn how to name this ester. Okay. Right, we can learn how to name the ester. First of all, everyone should understand the ester linkage. Ester linkage is this, where carbon with double bonded is bonded to the oxygen atom. That is the ester linkage. We call that ester linkage. Now there's ester linkage in any ester. So there's ester linkage here as well. Right, now listen to this. When we name the ester, we have 2 parts in the name of the ester. Right? We have 2 parts in the name of the ester. When we start naming ester, we start with the alcohol part. Right? So depending on the number of carbons that came from the alcohol, right, we name the ester. Also, we have to consider how many carbon atoms came from the carboxylic part. Right, now when we name this, which side is the alcohol part? This side is the alcohol part, right? So this part of the molecule came from the alcohol. Then this part of the molecule came from the carboxyl. Right, when you name, you start naming from the alcohol part. Right? So we need to count how many carbon atoms are there in the alcohol part. How many carbon atoms are there? We have 2, right? 1, 2. So 2 carbon atoms in the alcohol part. So we write the first part of the name like this. Right, 2 means it. Meth means 1. The alcohol part of the molecule has 2 carbons. Therefore, first part of the name is ethyl. 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 Right. Then the carboxylic part of the molecule has 2 carbons. 1, 2. Right. So in the carboxylic side, you have 2 carbons. Guys. Right. In the carboxylic side, we have 2 carbons, just like in the alcohol side. So when we write the name at the end, we write it like this: ethanoate. Ethanoate. Ethyl ethanoate. Now, the last part of the name is the special suffix we use for esters. Like for carboxylic acid, we use oic acid, right? For alkanes, we use ane, propane, butane, like that. So for esters, we use OH. So that is the suffix for ester. Now this ethane part came from the carboxylic acid part of the molecule. Guys, keep quiet. Anyone wants to go out on the first day out of the class? Keep quiet, huh? Right. So carboxylic part of the molecule has 2 carbons. So ethanoate, ethanoate. So if there are 3 carbons, propanoate. If there are 4 carbons in the carboxylic side, this side, right? Carboxylic side is that. Then we call it butanoate. Right. So ethyl ethanoate is the name. This is due to alcohol part. Right now, what I want you to do is write down this name and follow the same method and write down the name of the last one we did. We have drawn another ester. If you have completed, you can rest your hand. Okay, excellent. Did you write the name of the next one? Now we did another example. I gave another extra example. Name that ester as well. Name that one. We did another example. So, done. Done. Now this is ethyl ethanoate. Right, how many shall I have completed now? Name of the next one. Right? This guy already done. Ethyl ethanoate. Now this one is fine. Let's look at the name of the next one. What is it? What's the name? How do you name this? Propyl? Propyl what? Ethanoate? Butanoate? Pentanoate? Right. Let's look at the name. Now the alcohol part has 3 carbons. So we call it propyl. And the carboxylic part has 3 carbons. So it's propanoate. Propanoate. Propyl propanoate. Propyl propanoate. Right. Now we know how to draw the ester and also name the ester. Right. Right, we'll go to question number 5. Right, let's go to question number 5. Siloxane are condensation polymer. Now you don't need the knowledge about anything about siloxane, right? It's just they have given this polymer for the question, but they say it's a condensation polymer. Now when it comes to polymer, there are two main types of polymers. Two main types of polymers are there. Right, two main types of polymers are there. Polymers. Two types. One is addition polymers. The other one is condensation polymers. Right, now the name suggests addition polymers are formed by adding molecules. Right? Alkenes form addition polymers. Alkenes form addition polymers. So these alkenes undergo addition polymerization. Alkenes have carbon-carbon double bonds. But under condensation polymerization, we have learned many examples. Polyesters, right? We have learned about proteins, right? Polyamides like nylon, like polyesters like terylene. So we have learned about many condensation polymers. So in condensation polymers, always the molecules combine together, right? Many monomers, they combine together to make a bigger molecule or to make a polymer by removing a small molecule, right? Small molecule like water, not only water, sometimes HCl, like a small molecule is always removed. But when alkenes are added to each other, small molecule is not removed, but in condensation polymerization, monomers combine. Monomers are the reactants, right? Monomers combine to make a polymer by removing a small molecule during the reaction. So that those are called condensation polymers. So condensation polymerization is, let's write down the meaning. When monomers combine, when monomers combine to make a large molecule, in brackets polymer. So monomers combine to make a large molecule or large molecule is the polymer, removing small molecule. So monomers combine to make a polymer by removing small molecule. So underline the term monomers combine and removal of small molecule. But in addition polymerization, small molecule is not removed. In condensation polymerization only, small molecule is removed. Now, if you look at this siloxane polymer, there's a repeat unit in this one. Now, I'm going to give you a chance to identify the repeat unit. Repeat unit is the unit that repeats in the structure of the polymer. Right, let's see how many people can identify this. The certain unit that repeats throughout the structure of this siloxane, you can see the structure is given. Done? Can you see this? Right. Shall we check the answer? Can you see this polymer structure? The part of the polymer structure is given. Can you see there's always a silicon and one oxygen bonded to silicon, 2 methyl. Can you see this unit repeating throughout the one? Right? So see that unit repeats throughout the polymer. So that's the repeat unit of siloxane. So then when we draw it, we can draw it like this. So oxygen, silicon, 2 methyl groups. But you need to put a line to the silicon also. That's the unit. Because silicon, just like carbon, form 4 bonds, guys. So you need to put a line to silicon as well. That's it. Right, even if you have put the oxygen to left or right, doesn't matter. But one oxygen should be bonded to silicon. Let's say you have drawn it like this. Same thing. You just flip the molecule and draw it. Done? Correct? Okay. Right, let's go to this one. Butene forms an addition polymer. Alkenes always form addition polymers. Right? Now for an example, ethene forms polyethylene. Ethene, this is ethene. Right? For an example, guys, ethene is this. Now, if I draw the repeat unit of the polymer, what I need to do is, when I draw the repeat unit of this polymer, what I need to do is, there's a double bond, right? Erase one bond from that and draw the structure. And then put a bond to this carbon and bond to this carbon. That's the repeat unit of this polymer. And when you draw the structure of the polymer, we can use like 2 repeat units or 3 repeat units, right? Let's say you use 2 repeat units. So this is 1 repeat unit, combine it to another repeat unit. But is this correct now? There's an error in this one. What is this error? The first carbon and last carbon, look at them. There's only 3 bonds now. That's wrong. So what should I do? Put a line to this carbon and that carbon. Right, so you can see there are 2 repeat units I have used to draw the polymer. 1, 2. Let's look at another example. Right? Let's look at another example. Okay. Now there can be a alkene like this. So when I draw the repeat unit, guys, look at the code. When I draw the repeat unit for this, from double bond, keep 1 bond. Put H here, H here, H here, and a Cl here. Then to complete the repeat unit, put a bond here in the left hand side, also to the right hand side. That's the repeat unit. Right? Now we go to this question. Butane forms an addition polymer called polybutane. Draw a partial structure of polybutane. You must show at least 2 repeat units. Now they have given the structure of butane. In a weird way they have given it, but you can use the same method. Right, anyway, butane also can be drawn like this now. They have, we can also draw butane this way. CH2, CH3. Same molecule. CH2, CH3. Yeah, now this is an alkene, this is not the repeat unit. Yeah. Now you can draw. Now you have to draw the polymer with 2 repeat units. Shall we do like this? Shall we figure out the repeat unit first? Because if our repeat unit is wrong, then our polymer structure is wrong. So let's figure out the repeat unit quickly. Right, let's figure out the repeat unit quickly. Yes, I will do it in the. Right, figure out the repeat unit of this one. Now students get scared when the molecule is given this way, but they don't understand the molecule. Even if you draw this way, same thing. They have like given the angles here. It doesn't matter. You can draw it like this or this way. Right. When we draw the repeat unit, what did I say? Break the double bond. Make it a single bond. Very simple method. Double bond, you make it a single bond. So CH2, CH3 there, H is there, another H is there, another H is there. Right, now this is not complete. There should be a bond here in the left hand side, bond here. Now this is not the answer, this is the repeat unit. Did you all get the correct answer for repeat unit?
So if you just take that, we have given and then change the side.
Now what we need to do is we have to draw the polymer using 2 repeat units. Can you draw the structure of the polymer using 2 repeat units? Right, now draw the structure of the polymer. Polymer structure is the final answer. At least 2 repeat units you have to use. At least 2 repeat units. I will complete it. Now, this is a very easy thing, guys. If you don't understand how to draw, just look at the board. This is not hard. First thing that I would do is I will figure out the repeat unit. Then I just have to draw this repeat unit 2 times. Even Kade Mudalali can draw it. If I give the repeat unit to Kade Mudalali and ask him to draw polymer using 2 repeat units, he will do it.
Not Shehan and Kade Mudalali.
Definitely, Sumanati Mudalali will do it. Yeah, go and ask. Recently, I have done some individual tasks for them. Just ask and see. Now, anyway, now when we draw, you have to draw this repeat unit 2 times. Any baby can do it, right? So this is 1 repeat unit, CH to CH. 1. Now do another one. CH2, CH3, H. But now this is not final answer because I had to put a bond to the left and also bond to right.
We can draw more than 2.
You can draw more than 2, at least 2 repeated. At least 2 repeated. Right, we are going to do another question here before we go to the next part. So since we have space here in this page, right, I'm going to give you a structure of an alkene. Ready? I'm going to give you a structure of an alkene and you have to draw the repeat unit and you have to draw the polymer with at least 2 repeats. Right, let's do that. So I'm going to give an alkene. Right, this is the alkene. Then you must draw the repeat unit. You must draw the repeat unit and then polymer. You must draw the polymer. Right, I'm going to come and check randomly. Let's do it. That works. Right, first we have to draw the repeat unit. What we need to do is erase this double bond, make it a single one. So, now this is not complete. Now I see sometimes students don't complete their repeat unit. This is not complete. You have to put a bond at the start and also at the end. Then we have to draw two of these repeat units at least. So one CH3 here, CH3 here. Then combine to the other one. CH3 here, CH3 here. Then is this complete? Is this complete? No. Bond at the start and also at the end. Right, so that's how you draw the polymer and the repeat unit when the structure of the alkene is given. 18 May 22. Right, we'll go to question number 6. The diagram shows the partial structure of polyester. Right, now in polymers, we have condensation polymers. So polyester is a condensation polymer. Right, so polyesters are called condensation polymer. Now there are two types of polymerization. One is addition polymerization. The other one is condensation polymerization. Right, so polyesters comes under condensation polymerization. Right, so they have given the structure of a polyester, and you can see these are the ester linkages. This is an ester linkage. This is an ester linkage. There we have another ester linkage. So many ester linkages are there in polyester. Poly means many. So many study cases are there, polyester. Then they have asked, in part A, they have asked us to draw partial structure of nylon. Now, nylon is a polyamide. You can write down. It's not a polyester, it's a polyamide. Polyamide. So we have two polymers. One is under condensation polymer. We learn about two polymers that are man-made, synthetic. One is polyester, the other one is polyamide. So example for polyester you can write down. Terylene. Terylene is an example of polyester. An example of polyamide is nylon. Right, when nylon is formed, we're going to draw the partial structure of nylon. But I'm going to give a small note here about nylon. So to make nylon, we need two monomers like this. This monomer has a nitrogen bonded to two hydrogen, and not only one nitrogen, it has two nitrogens. Right? So we call them diamines. Diamine. So when a diamine combined with diamine plus, we have a dicarboxylic. So dicarboxylic. So in dicarboxylic, we have two carboxylic groups. So when a diamine combines with the dicarboxylic, when diamine combines with dicarboxylic, this nylon is formed, or polyamides are formed. Right, quickly draw this, and then we have to draw the nylon structure. You need space for nylon structure. So diamine and dicarboxylic combined form nylon, or called polyamides. Right, now when we draw the molecule, draw the structure of the polymer, what we need to do is, we need to remove the OH from carboxylic. Even when we draw esters, we remove the OH from carboxylic, right? And H from nitrogen. Right, mark that. Both the OH groups will be removed, and one H from this nitrogen, the other is from this nitrogen. Now, when H and OH is removed, what is the molecule that is produced? From H and OH, what is the molecule produced? Water, right? How many water molecules are produced in this case? Two water molecules. Because we are removing two OH groups and two H's, right? So two water molecules are formed. So you can write the byproduct, two water molecules. Right, now everyone look at the board. So what I'm going to do is I'm going to draw the structure of the polymer, this nylon. So when I draw, like, I need this part of the molecule to be combined with this dicarboxylic acid. Right. So what I'm going to do is I'm going to start from this nitrogen and draw up to this nitrogen. Look at the board. I'm going to start from this nitrogen and draw up to this nitrogen first. Right, so NH, that is a box. NH. Then the second nitrogen, where I put a dot, will bind to this carbon in the dicarboxylic acid. So I'm going to combine that nitrogen and carbon. So when they combine, right, so I'm going to start from here and I'm going to go up to this part. So carbon double bond, there's a box, again carbon double bond. But now this is not complete again. The two bonds from left and right. So nitrogen I need to put a bond, to carbon I need to put a bond. So that is the structure of polyamide. Therefore, nylon. That's the partial structure of nylon. Right, quickly through. So nylon is a polyamide. Pterylene is a polyester. But both are under condensation polymers. Now we have two main polymers. What are the two main polymers? Addition polymers and condensation polymers. Addition polymers and condensation polymers. Now these addition polymers are horrible. That's because they don't break down. We say they are non-biodegradable, right? So they can't be broken down by bacteria. But these condensation polymers, they can be broken down. So polyesters, nylon, or pterylene, they can be broken down by bacteria. But polythene, polypropylene, these addition polymers cannot be broken down by bacteria. So they are non-biodegradable. Addition polymers are non-biodegradable. Right now, we're going to do part B. Right. The diagram shows the partial structure of an addition polymer. Right. Now, addition polymer partial structure is given. Okay. Now, what is meant by the term addition polymerization? So, when we wrote the definition for condensation polymerization, we say it is when monomers combine to make a polymer by removing small molecules. Monomers combine to make a polymer by removing small molecule like water. But when addition polymers are formed, no byproducts are formed. Only the polymer is formed. Remember that. When addition polymers are formed, no byproducts are formed. Only the polymer is formed. So we can write down. Therefore, can write down. It's a reaction where monomers combine to make, it is a reaction where monomers combine to make a polymer and no byproducts are formed. No byproducts are formed. So monomers combine or monomers react to make a polymer, and especially we have to write down no byproducts are formed. There are no byproducts. No water molecules produced in this case. Addition polymers are formed by adding alkenes. No byproducts are formed. So that's the difference. Now, part Roman number 2, you all can do the finish. Now they have given a polymer, guys. You can see that's an addition polymer. We have to draw the alkene that can be used to make this addition polymer. Right? Can you all give it a try? I believe you all can do this one. So we can do the alkene. No, they're asking for the alkene, not the repeat unit. Then if they're asking for the repeat unit, they will say, those are repeat unit. Alkene is the monomer. Monomer is alkene. Right. What's the alkene? What's the structure of the alkene? If you identify the repeat unit, you can identify the alkene. So repeat unit, when you put a double bond, you get the alkene. First, better to identify the repeat unit. Quickly, guys, do the question. Don't do other things. Good. So you can see now the repeat unit for this one is this. That's the repeat unit. So repeat unit basically, but they are not asking for the repeat unit. This is the repeat unit. So if you identify the repeat unit, you can identify the structure of the alkene easily. Right, so that's the repeat unit, right? You all agree, right? Then what's the structure of the alkene? You just have to put a double bond in this. So the alkene is the one that produces this repeat unit. So the alkene structure should be this.
So the difference between the repeat unit and the alkene is basically the double bond in the middle and later
Yeah.
on there two bonds on the sides.
Yes. Right? Did you get this one? Right. Roman number 3. Right. Describe one pollution problem associated with disposal of addition polymers. Now, addition polymers are non-biodegradable. You can write that. That's one problem. Or we can say they causes litter. Another thing we can say now, the thing is when we try to dispose these disposal of these addition polymers can be done by burning them. But the thing is when this plastic, when you burn, toxic gases, so pollutant gases can be produced, right? So also we can fill these plastic into different landfill sites. Then the thing is it fills up landfill sites. So we can write down here's landfill sites. So one of these answers we can write down. And also we can write down incineration. Incineration means burn of addition polymers produces toxic gases. So incineration of addition polymers will produce toxic gases. So therefore we should not, they actually burn the plastic, but that is not good because it produces toxic gases or pollutant gases. So that's the problem with addition polymers. They are non-biodegradable. Therefore, these are the problems. Right, we can go to page number Next page, we have an ester. Right. Now we have an ester, guys. We just did a question about ester. Right. So ester A has this structure. Can you name this ester quickly? When we start the naming of ester, we start by naming from the alcohol part. Alcohol part first, then the carboxylic part second. And what's the suffix of ester? OA. Right. Now, if you can't remember, you can go back and quickly find. Good. Right, name ester A quickly. Right, how many of you have completed? Girls have you completed? Yeah. Is it difficult, this one? Difficult? Ayyo, even Kademudra can name this ester now, huh? Okay, so if you look at the alcohol part has 1, 2, 3, 4 carbons. Always remember, in the ester, the carbon double bond comes from carboxylic. Because carboxylic has this carbon double bond. So alcohol part is the right hand side of the molecule, you can see in this case. 4 carbons are there. Yeah, 4 carbons are there in the alcohol part and 2 carbons are there in the carboxylic. Can we check the name again? Can you check the name again? Alcohol comes first, then comes the carboxylate. How many carbons are there in the alcohol? 2? This is the alcohol part. 4. So what do we call it? Butyl. Butyl. Then there are 2 carbons in the carboxylic part. Butyl ethanoate. Butyl ethanoate, right. Right, let's go to the part B. Ester A reacts with hot aqueous sodium hydroxide to give compound B and C. Compound B has percentage by composition by mass. Right, carbon percentage is 29.3, hydrogen is 3.7, oxygen is 39.0, sodium is 28. Now we have to calculate the empirical formula. We have this method when we calculate empirical formula. We find the molar ratio of the atoms. So we have carbon, hydrogen, oxygen, sodium. Now you can see they have given the percentage of each. So write down their percentage, 29.3 by mass. Third, 3.7. 39, 28. Then we need a periodic table because we are finding the mole ratio of atoms now. When we find mole ratio, the mass percentage, we are divided by the atomic mass of each atom. Atomic mass of each atom. So what's the atomic mass of carbon? 12. So you divide this by 12. And this one divided by 1. Hydrogen's atomic mass is 1. Oxygen is 16. Sodium is 23. So divide each one's percentage by mass by its atomic number. Now take the calc. Right, quickly solve this. Find the empirical formula, guys, quickly. Right, so 29.3 divided by 12. 29.3 you divide by 12.
2.4416.
So you get 2.44. Then 3.7 divided by 1 should be 3.7. 39.0 divided by 16.
2.437.
2.4. So that's also 2.44. No, roughly. Right. Then 28 divided by 23. 1.22. Now we take the smallest number out of these numbers. Smallest number is 1.22. So we divide each by 1.22. So the simplest whole number ratio you get is 2 is to 3 is to 2 is to 1. That's a formula, empirical formula. C2 H3O2 Na. Did you all get this formula? C2H3O2 Na. C2H3O2 Na. Which one? Because there's 2 carbons, 3 hydrogens, 2 oxygens, 1 sodium. Right, so there's 2 carbons, 3 hydrogens, 2 oxygens, 1 sodium. That's why it's C2H3O2 Na. Right, let's go to Roman number 3. Right, compound C has a relative molecular mass of 74 and is oxidized by warm acidified potassium manganate to give butanoic acid. Please keep quiet. When I discuss a question, you need to keep quiet. Right, compound C has relative molecular mass 74. Right, relative molecular mass is 74 and is oxidized by KMnO4 to produce butanoic acid. Right. Now butanoic acid. Now we'll take one example. So you can make ethanoic acid. Ethanoic acid is formed by ethanol. So oxidation of ethanol will produce ethanoic acid. Oxidation of, everyone look at the board. Now some students are not listening. Right. Ethanoic acid can be formed by oxidation of ethanol. Right. So butanoic, propanoic acid can be formed by oxidation of what? Which alcohol? Propanol. Right? So ethanoic acid is formed from ethanol. Propanoic acid is formed from propanol. Then butanoic acid is formed by what? Butanol. Butanol has how many carbons? But means how many carbons? 4. So it's an alcohol with 4 carbons. So can we draw a structure for C then? C should be definitely the alcohol butanol. So can you draw structure of butanol? Right, so when we draw, we can put 4 carbons in straight chain. We can put the OH to this carbon and then complete the structure by adding hydrogen atoms. Now, since they have not asked for displayed formula specifically, student can also use structural formula. Like you don't have to show all the bonds when you draw. You can also draw it like this: CH3, CH2, 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 OH. Now we have to explain the answer, right? So we figured out C is butanol because the carboxylic acid has 4 carbons. The alcohol should be having 4 carbons in the structure. Right, so we can write the explanation for this. Right, quickly copy down this. Have you all finished copying? So we can write the explanation. Right? A mass. You can use the mass also to control. So there are 4 carbons.
So, but if it, that would be only if they give the mass. That would be only if they give the mass.
They have given the molar mass, but you don't need that specifically to find out. You can double check with the molar mass. Right, so we can write down C should be an alcohol with 4 carbon atoms. Right, so butanol produces butanoic acid, pentanol will produce pentanoic acid. So compound C should be an alcohol with 4 carbon atoms. Right, you can go to the next page. Yeah, for structure you get 1 mark, for the explanation you get 1 mark. 2 marks in the question. Quickly copy down, guys, quickly. Right, next question is about isomers. Now, right, isomers, we have talked about isomers. Isomers have same molecular formula, but different structural formula. Right, same molecular formula and different structural formula. Now, for an example, this is an alkane with 4 carbons, guys. Right? Then I can draw an isomer of this. So when I draw an isomer of this, I need to draw different structure, can't be the same structure, right? So isomer of this. So what I'm going to do is I'm going to put 3 carbons in the straight chain and 1 carbon in the branch, right? So we can So this is a different structure, right? But for them to be isomers, we have to double check the number of carbon atoms. In both, do we have same number of carbon atoms? Yeah, how many carbons? We have 4, right? In this one we have 4, in this one we have 4. How many hydrogen atoms in the left hand side one? 3, 2, that means 5, 7, 10. H10. Check the other one. 3 here, 3 here, 3 here, 9. Plus 1, 10. So isomers are molecules with same molecular formula, but with different structural formula. Structures are different. So you can draw this example, then we can write the definition. Right, let's write the definition. Compounds with same molecular formula but different structural formula. Compounds with same molecular formula but with different structural formula. Same molecular formula but different structural formula. Those are called isomers.
So what's the difference between isomers and
Isomerism is the process of making isomer.
If we write the definition of
Isomer, that's it.
but we did learn isomerism.
Isomer and isomerism, same thing.
But we should have to know the detail, the process in detail, right?
You mean the process? No. Right, now we are going to draw. Right, let's see how many of you can do this part. Draw an isomer of ester A. Now this ester A has how many carbons in total? We have 6 carbons, right? So you have to draw a structure of an ester with 6 carbons. Now I'm going to do one example and then look at the board, everyone. So there are 6 carbons in ester A. So I'm going to draw the ester in a different way. Because in this ester, we have 2 carbons only in the carboxylic side. I can put 3 carbons to the carboxylic side, right? So I can draw an ester like this. 1, 2, 3. Yeah, any. 3 carbons to the carboxylic side. And how many carbons to the alcohol side? Now in the ester, stop talking. In the ester, there are 6 carbons. In ester A, there are 6 carbons. So I have to draw another ester with 6 carbons. So when I do this, I can put 3 carbons to the left hand side and 3 carbons to the alcohol side, right? So 3 carbons, now 3 carbons to the carboxylic side. Now I have maximum 6 carbons only. So if I use 3 carbons to the carboxylic side, I have only 3 carbons to be used in alcohol side. So then this is an isomer of A. Ester, this is different. Because yeah, in isomers the names are also different because the structure is different. Get it? Right? So this has a different name, right? So what's the name of this? Propyl Propyl what? Propanoate. Now I want you all to draw a different one. Now, can you also draw another one now? With you can copy this as one example. We can draw many now. I saw like three students so far got different structures. Can you also try and find a different structure other than the one I have drawn? What's the name of it? Is it a branch one? Yeah. Then it's fine. Because we have it's okay. Your answer is correct, but we can't name the branch one because it is we have named the branch. But can you draw a different ester?
No branch.
We can put branch. Easiest thing is you can put branches and draw. That's no problem. Easiest thing is you can change the number of carbon atoms in the alcohol side and the carboxylic side. So shall we look at another example? Right, can't we draw like this? Can't we put 4 carbon atoms to the carboxylic side? We can. We can put 4 carbon atoms to the carboxylic side, right? 1, 2, 3, 4, double bond. And oxygen. Then if I put 4 carbon atoms to the carboxylic side, how many carbon atoms should I put to the alcohol side? 2. Because I can use maximum 6 carbons. Because A has 6 carbons. When I draw the isomer of A, number of carbon atoms should be same. So I can put 2 carbons to the alcohol side. What's the name of this one? A name. Bit different. It's okay. We don't learn in the whatever. Right, what's the name of this one that I've drawn? Ethyl. Ethyl what? Ethyl butanoate. Right, like that. Now the thing is, even if you have drawn another structure, what you need to check is whether you have 6 carbon atoms. Let's say you have drawn a different structure, not these structures are given. Check whether you have 6 carbons in the structure. And there should be 2 oxygens. Huh?
The structural formula is the same.
Structural formulas are also different.
Both the ether.
This is propyl. You mean this one is butyl ethyl. This is ethyl butyl. You can't do that. That's the same thing. Right. Check your answer. Check the number of carbons. There should be 6 carbons. Right. There should be hydrogens. We have 5 here. We have 7, 9. 9 plus 3, 12 hydrogen should be there, 2 oxygen should be there. Now we are drawing this isomer of this. No, these are 6 carbons, 12 hydrogens, 2 oxygens. So isomers should have same molecular formula, but different structure. So both of them have same molecular formula, C6H12O2. C6H12O2. Right, so when you check your answer, check whether there are 6 carbons, 12 hydrogens, and 2 oxygens. Right, let's go to part D. Right, explain why ester A is a saturated compound. boys. What's wrong? Right. Explain why A is a saturated compound. Saturated means there can't be any carbon-carbon double bonds. Do we have carbon-carbon double bonds? No carbon-carbon double bonds. So saturated means there are no carbon-carbon double bonds. So A is saturated. You can write down because there are, because you can hear, right? Because there are no carbon-carbon double bonds. Or we can say, now one answer is because there are no carbon-carbon double bonds. And or you can say there are only carbon-carbon single bonds. Huh? Four? No, yeah. There are only carbon-carbon single bonds. There are only carbon-carbon single bonds. So your answer is correct. If you have written there are no carbon-carbon double bonds. Yeah, only for carbon. This is wrong. Right, because there are no carbon-carbon double bonds, or there are only carbon-carbon single bonds. Only 2 hours. Right, so today we are doing only 2 hours, but we are going to do the class for 3 hours soon. Because we need more time, guys. We need more time. Right, now listen. Now we will do. Don't pack. Wait. I'm getting one question. Right. Listen. Now we will do like section-wise revision, and then also we will do like full papers. Questions will be taken from MCQs, paper 4, paper 2, like that. Right. Also, one more advice. Everyone listen. Now here, if you want to work, only you need to come to this class. Otherwise, if you want to have fun, please don't come to this class. Because the idea is we are going to help you to somehow get a really good mark. Because there are students who are in the range of B, they still can get A star. Right? As I mentioned previously, there are students who got like for mock exam like 43, but for O-level final exam they get 92, right? But now in the next class, if I find anyone not doing work, wait, where are you? Wait one, until I complete your way. You don't know the rules, no manners, right? Now, if I say anyone not working, guys, straight away I'm going to send you home. You can refund your money because I don't want any bad influence in the class. You all need to work super hard because when I start more calculation, you can't start talking to the other person and then learn from that, right? When I start more calculation, there will be a lot of calculation to do. So if someone is not doing work and not bringing any calculator and not doing what I'm saying, we have to remove them, right? No mercy, because we have only few months, 4 months to complete everything. You have to be in the game. If you are not in the game, that means you are not the best influence for the class or to anyone, right? Therefore, you have to be in the game. Do whatever I tell you to complete. If you don't know the answer, it's fine. But if you are doing something else, or if you are not writing anything, right? If I say like if you are not writing the answers, even if you don't know the answer, when I write the answer, you can write it, right? So if you are not doing that, then that means you are wasting money here. you can find different place, right? So therefore, from next day, remember, discipline is important, and also you need to work really hard, right? Okay, good night everyone, we'll see you next time.